Okay, so we are going to talk more specifically about bicycle subsystems. And this PowerPoint and this lecture will be using a template that I handed out in class and is also available uh, to you on the Nomia site where this lesson is housed. But very briefly, let's review what we know about technological systems. We know that a system is a group of parts that work together to try to achieve a specific goal or purpose. So if we think in terms of a bike, there's a lot of things that maybe we would want to accomplish with a bike depending on its design. So this particular guy has quite the mountain bike, doing all kinds of crazy maneuvers. So this particular type of bike has a specific design in mind to it, and its goal essentially is to be able to transport its rider through challenging trails on a mountainside. So if we think about, again, what the components are of any technological system, we can use this to frame our discussion about bicycle subsystems. So remember that every system has a goal. So in this case, this other picture here, we have a roadster type racer, and so obviously with this bike we want to be able to go as fast as possible. So there's specific design elements related to that goal. And this poor soul is leisurely driving through the country. Maybe she's on her way to work or whatever. Obviously doesn't need to go real fast. A simple kind of point-to-point type of bicycle is all that she would need. This dude, on the other hand, trickster, so he's got all kinds of things going on here. And obviously there'll be a very specific goal in mind for this bike that will determine its design. And again, the other four components of any technological system include the input, process, output, and feedback. So that's a review. And in terms of the bike, even though there are many subsystems to a bicycle, we're just going to consider three for the purpose of what we're studying now. One is the propulsion subsystem, which is also called the power system. So if you think in terms of, if you've ever had the drink Propel, that whole point is to give you energy to move forward. So that is what is the goal of a propulsion subsystem, is to move forward. A guidance subsystem, obviously, we want to guide through mountainous terrain, or we want to guide through city streets. That's going to be a steering subsystem. And then finally, our control, our braking subsystem. And I'm going to use a diagram to help us walk through descriptions of each of these subsystems. So we're going to be describing them in terms of those five components of a system, but I'm going to add another element to it, and we're going to actually identify the individual parts that make up each of those subsystems. And this is how I'm going to be explaining this. It's a little awkward, but we'll figure it out as we go. Obviously it's a diagram, and if you notice that there are words that are located around the part that they are representing. So here we have a tire, and we have a rim on the inside with spokes that connect it to the hub. We've got a fork that's connected to a head tube, which is connected to the stem, which is connected to the handlebars, and that has the brake lever attached to it. So we have a whole bunch of different parts indicated on this diagram, and we're going to be touching upon most of them in the context of our discussion today. The notes page that we're going to be using is something that was attached to the lesson on Nomia when you went online, and it's also the sheet that I handed out in class, so you're going to be using this to take notes as we go. So if you notice at the top, there's a column for propulsion and power system, a second column for guidance and steering, a third column for control and brake, and then we've got parts, goal, input, process, output, and feedback listed on the left-hand side. So you can tell by looking at this that we're going to be talking about the power or propulsion subsystem along with all of these different categories, the parts, the goal, the input, process, output, and feedback as we go along. And we'll do the same thing for the guidance and in the control subsystems. So let's start with the propulsion subsystem, and I'm going to try to see if I can get a highlighter here to help us outline how this is going to go. Give me a second. Here we go. Here's my highlighter. All right, so let's use green. We'll use a green highlighter for power because green means go, right? All right, so here we go. Let's start with the goal. So the goal of our propulsion subsystem is to move forward, just like the Propel fruit drink that I mentioned before, the sports drink. We drink those because we think it'll give us energy, so we are moving forward. So propulsion means to move forward. The input of our propulsion system is the energy that we exert through our legs to pump on the pedals. So down here we have our pedal. So we're going to be pushing down on this pedal with our legs, and that will make the pedal move forward. Now the process that happens, remember, it's that sequence of action steps that take us from our input to our output. So we've got a bunch of things going on here. When we push down on the pedal, it turns the crank, which in turn turns the chain ring, which in turn moves the chain. So here's our chain, and yeah, I'm using my mouse, so this is really awkward. It's not as smooth as I want it to be, but I think you get the idea. And then when that happens, the chain turns this freewheel, and that's what's located here. Okay? And that in turn makes the tire and the rim, which make up the wheel, it makes that wheel turn. That is one heck of a wheel. So that's the process. When we push down on the pedal with our legs, we turn the crank, which turns the chain reel, which turns the chain, which turns the freewheel, which turns the rear tire and rim, otherwise known as the wheel. So that's the process involved with our propulsion subsystem, all starting with energy from our legs, pushing down on those pedals. The output, we hope, if all goes according to plan, is that our bike will move forward. But as we've learned, sometimes with systems, they don't always work out the way we want. If our output doesn't equal our goal, then we've got some feedback that we need to look into. So feedback, in this case, could be, we could look at it from the vantage point of we see an uphill coming. If we don't push harder down on those pedals to keep moving forward, that bike will naturally slow down because of gravity. So we're going to have to put some more energy on there to make sure we're moving forward. So remember the parts then that you can enter this into that that row of your worksheet. The parts that we are including in our propulsion subsystem include the pedal, the crank, chain ring, chain, freewheel, and the rear wheel. All right. Now let's move on to our guidance steering subsystem. So our goal with this, obviously, if we're trying to steer through stuff, we want to be able to move either to the right or left to steer clear of whatever obstacles might be in our way. The input, again, is energy. This time it's from the arms that we use to push and pull the handlebars. Pushing and pulling it so we move either right or left. So there's our handlebars. Now the process, again, that series of action steps that take us from our input to our output are as follows. So our handlebars are attached to the stem, so that gets turned, and that turns the head tube, which then turns the fork. Here's our fork, and that turns our hub, right there, and that in turn will make the front tire and wheel, front tire and rim turn in this horrible circle, which is our wheel. So that is the very basic way of explaining what the subsystem is, the steering subsystem for our bike. And again, hopefully our output meets our goal, that we are actually able to move that bike either right or left, but sometimes that doesn't happen, especially if you're going really fast and you've got a turn ahead. So you're going to have to figure out how much push or pull those handlebars need to have depending on how fast you're going. So if you're going really fast, you're going to have to be gradual with your force, or you might fall. So the parts, again, need to reflect what's going on in the process. The handlebars are here. The stem, good. Head tube, okay, we've got that covered. The fork, yep, it's included. The hub and the front wheel are all part of the process, so we are in good shape. We've covered every part that's in our process has been listed in our parts section. All right, one more. Here is our control or braking system. So our goal is to slow down or stop. The input for our braking subsystem is the energy from our hands squeezing the brake lever. Okay, so there's our brake lever. We know that this is on the handlebars. So if we use our energy from our hands to squeeze the brake lever, that's going to result in the brakes on both the front tire and the rear tire to squeeze onto those tires, and that happens by way of cables. Now those cables aren't on this diagram, but I'm going to fill them in for you so you know where they are. There's one, and then this connects really awkwardly across the frame down to those brakes. So the cables carry that tension from the squeezed brake lever onto the brakes themselves, and that makes the tires on both the front and the back of the bike slow down or stop. Hopefully our output matches our goal, that the bike does indeed stop or slow down, but we know that doesn't always work, especially when you need to adjust your force depending on how immediately you need to slow down or stop. So if you're riding down the street and you see a car pull out of a driveway in front of you with no warning, you're going to have to squeeze that really, really hard in order to stop in time so you don't crash into that car. So let's check our parts. Okay, so our parts, we've got the brake levers, we've got the brakes, front and rear rims, and the brake cables, and they match completely what we have in our process. So we always want to make sure that our parts match whatever is in our process. They always have to be involved. And that is all we have for today on bicycle subsystems. Good job.